Hello everyone, today is section 9.3, transforming functions, and I am on my own. The essential question is, how do I transform piecewise functions? We learned about piecewise functions last lesson, and you're very familiar with transformations. Here is a table explaining again what happens when you have a transformation. Horizontal transformation is left or right. Vertical is up or down, reflection across the y-axis and the x-axis, and a stretch out front. We're very familiar with that, so we're going to just go right to it. Horizontal, now this is important though. Horizontal translations, and I'm going to draw like a star here. Oh, that's not what I meant to do. Let's try that again. Horizontal translations. This is what it says. Change both the rules and the intervals of piecewise functions. Vertical translations change only the rules, and I will go over that. Let's see what we have here. I think we're ready for the next page. On the next page, let's go on to our first example. We have a piecewise function. It says write the rule g of x given we want a vertical stretch by a factor of 3. So what that means is we're not going right or left, we're not going up or down, we're not changing the interval, we're changing the rule. If we have a stretch, so let's create so g of x equals, a stretch of 3 means you're multiplying each function by 3. So we're going to get, if you take 3, you're going to take 3 times this function and 3 times this function. When you do that, you get negative 3 over 2x and 3 over 2x squared. Up here, if x is less than 0 and if x is greater than or equal to 0. Remember, we're not going right or left, so the interval does not change, only the rule changes. And that is example number 1. Example number 2, I'm going to scroll down. You're given a function, you need to write the rule for g of x. We have a horizontal, so here we go, horizontal translation of 4 units to the right. So then we know our interval, our rule is going to change, and our interval. So g of x, this is how we do this. And we're going to take, remember, when you're doing horizontal, your x value, what's added or subtracted to your x value is what's changing. So we're going to have x minus 4 plus 3 if x minus 4 is greater than 0. And underneath, we're going to have 2 times x minus 4 plus 3 if x minus 4 is less than or equal to 0. And now we're going to solve these. We can do that. So x minus 4 plus 3 is just going to be x minus 1. If we add 4 to both sides, we're going to get x greater than 4. Over here, we're going to distribute that 2, and we're going to get 2x minus 8 plus 3 if we add 4 to both sides, x is less than or equal to 4. Well, we're just about done, but not quite. We still have x minus 1, but underneath we have 2x minus 8 plus 3, which is the same thing as 2x minus 5. On top we have if x is greater than 4, and right down here we have if x is less than or equal to 4. And I'm going to fix one little thing. I don't really like how that 5 turned out. Let's fix that. That should be a 5. There we go. And let's fix that x just a little bit. There we go. So that's g of x, x minus 1, 2x minus 5, if x is greater than 4, if x is less than or equal to 4. When you do a horizontal transformation, remember, the rule and the interval changes. So look at the graph. We're shifting 4 units to the right, and that's exactly what we did. We started with the f function, and we shifted the f function 4 units to the right to get the g function. Okay, I think we're ready for the next page. Example number 3. I think we're going to save example number 3 because if I recall, we went to the right on example number 2. Let's save example number 3. And let's go to example number 4. Write the rule for each function, or for the function in this case. We're going up. So remember, when you're going up or down, all that's changing is the rule, not the interval over here. So we have 5 minus x plus 4 if x is less than 5. And then we have 2x plus 4 if x is greater than or equal to 5. So we can combine like terms. And this is going really slow here. My goodness, the internet is not working very well. There we go. 5 minus x plus 4. So let's start with x. Negative x. And we have 5 plus 4 is 9 if x is less than 5. And down here we have 2x plus 4 if x is greater than or equal to 5. And this is our final answer. Just double checking everything. Everything looks good to me. I don't have Miss Boyd as my double check. So all we did when we did a vertical translation, we just added 4 to the back end of the function, and we did not change the interval at all. All right, next page. Example number 5. I think we should do example number 5 because we're going to the left. So let's do that. I'm trying to think what else we have going on this. Oh, not a lot. That's about it. Okay. 5 units to the left. Remember, left and right. Oops, I did not want to do that. It's opposite of what you think when you're going left or right. And so 5 units to the left. There we go. I'm trying not to do that. So we have, let's fix that. We're going to, whenever it's right or left, you're going to change the x value. So it's 2, and it's going to be x plus 5 instead of just 2x, x plus 5. That means to the left, minus 2. If x plus 5 is less than or equal to 3. Again, because we're going to the left, we're changing the rule and the interval. Negative 4, x plus 5 plus 16 if x plus 5 is greater than 3. Well, we can combine like terms. And we get, oh, yikes, that's not right. Try that again. We get 2x plus 10 minus 2 if x is less than or equal to, if you subtract 5 on both sides, negative 2. And down here we get negative 4x, wow, this internet's slow, minus 20 plus 16 if x is greater than negative 2. Again, we subtracted 5 on both sides. Well, I think we can finish up here. Combine like terms, 2x, we have 2x plus 8, because 10 minus 2 is 8, if x is less than or equal to negative 2. And then we have negative 4x minus 4 if x is greater than negative 2. I think that is a beautiful answer. Let's double check that it is right. Just double checking here to make sure we all are good, and we are. We changed the interval and the rule. So that's 5 units to the left, 7 units to the right. I think we can save that for class. And we have 2 units up. I just want to see what else we have. Oh, you know what we're going to do? We're going to do example 6, actually. 7 units to the right, because I think you need a little more work on that. So let's do 7 units to the right now. Okay? So 3, instead of just 3x, it's x minus 7 plus 2 if x minus 7 is less than or equal to 0. And here we have x minus 7 squared if x minus 7 is greater than 0. Well, let's see what we have. We can distribute the 3. We have 3x minus 21 plus 2 if x is less than or equal to 7. Add 7 to both sides. And we're going to leave, I'm not going to make you FOIL this out. I'm going to let you leave it as a binomial squared. And all we have to do now is combine like terms on the top. 3x minus 19 if x is less than or equal to 7. And then we have x minus 7, the quantity squared, if x is greater than 7. I think we'll circle that, and I think, let's check, I think we're good. Yeah, looks good to me. So notice again, when you do a horizontal transformation, the rule right here, and so up here, the rule and the interval both change when you're going to the right or the left. And this is up. We're going to do that in class. And oh, look at this. We have, right, the rule when you're going 4 units down. Very easy. And then question number 2. We will see you tomorrow.